We zijn weer live.
We zijn live. All right. Welcome, everybody, in the second part of our event for today. We have two sessions to go and then a discussion afterwards. And we'll now start with Fako Berkers from the TU Delft. Please, Fako, go ahead.
Thank you. Yeah, thank you for inviting me. Together with Sonja van Dam, I looked at grading open questions through a rubric. Looks familiar now. I am an engineer. I'm an innovation engineer, so I use new technologies and try to apply them. Sonja van Dam is assistant professor at the TU Delft, and she gave me the data for her Sustainable Development Goals exam. That's a second-year exam, where the bachelor students have to answer questions relating to the trade-offs between the different development goals. So they are sometimes at odds with each other, and the students have to argue how they are in conflict with each other, and in concrete cases, what the effects are. So we looked at those kinds of questions, but before I want to go on to that, I feel that there's kind of a bit of a difference sometimes of how people look at these AI systems, and my view is that these generative artificial intelligence systems are not the same as artificial general intelligence, meaning that it's super interesting technology, but it's not intelligent. And I have one slide to explain it. So this experiment has been done a long time ago, and it's with people that have epilepsy, and they were they had the connection between their brain halves separated surgically to help them with their epilepsy. But then science could study these people, and this is one of the questions that they asked. So they would show one brain half of this person the chicken claw, and the other brain half they would show a snow landscape. Then they would ask some photos lying in front of this patient. Can you point with one brain half? Can you point towards something that's related to what you've seen? And so one brain half would point to the chicken, and the other brain half would point towards the snow shovel. And then it became interesting because the patient was asked why. And then one brain half has nothing to do because there's no language there. So it is in nirvana, it's just being completely in heaven. While the other one has to kind of figure out, all right, I saw this chicken claw, I pointed at the chicken, I also pointed at the snow shovel, but it didn't see the snow landscape. So why did it do that? And then it says, the snow shovel is necessary to clean up after the chicken. So this language center that we have is very good at explaining the things that we do, even though it doesn't necessarily understand exactly what has happened. So it tries to make a story out of the context that it saw happening. And this is a great book, Why Everyone Else is a Hypocrite, by Gerspan. He summarizes very clearly how this language system is super important for us, and everybody has it. And we're sometimes seen hypocrites because the things that we say are not always the things that we do. And I think this is a very central idea, and I think we made an artificial version of this language center. And that's why I'm calling it a large language model and not AI. And I'm not alone in this, a lot of people do that. But this is my take on the new technology. All right, so to the automatic grading, similar to the previous speaker, the lecturers provided open questions about the sustainability development goals, and they also gave the correct answers through a rubric. So people would get 2 points if they mentioned certain terms and trade-offs, or they would get minus points if they said something completely wrong. So the students answers the questions in a digital environment, and then the large language model could get to work. So the rubric description is kind of matched with the best criterion that is found. And it was allowed to say, I'm uncertain about a certain criterion. And it was also allowed to give a comment. And that was kind of a free text, just say whatever you want to say kind of field. So I was asked these 3 different questions. And so in my view, this is a linguistic operation and not one of intelligence. Of course, you need to understand the jargon of cradle to cradle and the tectocycle and the biocycle. But it's a pure linguistic operation, and it's not one of intelligence. It doesn't require planning or making priorities and that kind of stuff. So that's why I think these systems have a chance of making good answers for these kind of exams. So what did I measure? I measured the percentage of questions that were graded as certainty. So if it would put uncertain criterions in there, then it would say, okay, well, then you didn't answer it at all. And I also looked at the mean absolute error. So that is how much points did the large language model deviate from the answer of the humans. And I also looked at the consistency. It was already discussed a little bit that humans, when they have the same rubric and the same answers, they will very often slightly deviate. And this is a measure to see whether this deviation is within reasonable bounds, basically. That's the kind of answer I'm trying to look at. I do this, like I said, I'm an engineer, and I do this in my spare time. So there are some limitations. I took the rubric from Sonja, which was like her notes, basically, about how to look at those questions and answers. And I added them into the system by hand. So I took 5 questions to start with out of the 32. But I did look at all the 263 students. And what's maybe interesting, this comment that was there about energy use, which is a very good comment. However, like a teacher looking at a screen, doing this work takes a lot more energy than a system doing this stuff in the background. Right? I mean, hours of looking at a screen is a lot more energy than like it takes a few minutes when you kind of optimize it. So I think that's important to say. I had one problem with the rubric where the points could be equal. So if a grader gave 2 points, then I wouldn't know which rubric was chosen or which criterion was chosen. So that was that's a limitation in the available data. And I only used OpenAI models. And it would be interesting to use Google, because Google is probably less likely to be kind to the students. So that's really something I want to try. Right. So the results. First, O1 Mini. It's a fast and cheap reasoning model, quote unquote. And I used a tree and voted approach. So I would ask it 3 times, the exact same question. And then the thing that was answered the most would be the thing that that would be the grade that the system gave. If they would all disagree, it wouldn't be able to answer the question. So 39% of answers was graded. The mean absolute error was 0.5, and the scale is between 0 and 4 points. However, there was no significant ICC2, so it's questionable whether this is usable in practice. The second thing I tried was this GPT 4.1. And that is specially made for automatic usage. And there the results shot up, so it was able to answer 66% of questions with the same mean absolute error, but the variance was also lower. So that's a very good sign. And the ICC2 became reasonable to good.
Can you explain what ICC2 was? There's a short question on that we forgot.
I think it's between 0.6 and 0.7 somewhere.
It stands for?
Intra-class correlation.
Okay, intra-class correlation.
Two. Yeah, there's 3 versions. Next, I tried to reason about what would happen if we would have a human in the loop. So my first attempt was, right, we have all these answers that are marked as being uncertain by the large language model. What if we would give those criteria to a teacher or a lecturer, and they would be able to say yes or no to apply the criterion or not. Unfortunately, that didn't do much. However, my second approach was to have graders look at all the questions that had any comments. So the large language model, as soon as it tried to speak into this free text field that it was allowed to dump their text into, as soon as it did that, I would say, okay, a human grader has to look at this question. And what that happened then is the amount of questions it could answer dropped significantly, like by half. However, the errors also dropped significantly, and the ICC2 became good to excellent, which means that it very narrowly follows the human graders. Of course, because partially they answered the questions. So I think that is a very promising kind of result, something to say that is interesting. And I think if we would go on with this, it would mean that the workload would shift from being from grading to creating a strong rubric. That's what I'm expecting. Because, like I said, Sonja Verdam, she had her own, and her team, by the way, had their own notes of how to make sure that that they are consistent. But those notes apparently are not specific enough for this language comparison to be very successful. Especially things like sufficient. You know, what does sufficient actually mean? Like, as a human, we have kind of a feeling for that. But for this large language model, you have to be very, very specific about what that is. So the work would shift from, okay, I have these notes for myself, and they have to become very, very narrow. But I think AI systems could help, like you also described, Sylvester, they can help with creating these good rubrics. And my second finding is that, yeah, I used a very small data set in the end. And I'm looking for collaborators to share more with me, especially people that have data where the ICC2, so the consistency between human graders is very high. That would be super interesting to look at. And concerning privacy is also a very important thing. I do use the American models, not the local host stuff. However, I don't need to know anything about the students. I don't want to know, right? So I get student 1, 2, 3, 4, 5, and that's everything I will ever know about them. So in that sense, it's quite safe to share. Yeah, and so the question becomes, should we continue this or not? And I think there's a few interesting kind of alleys that we can go into, which I quickly want to describe. One would be to have it as a formative assessment tool, so we don't use it at the end, but we use it halfway to see how far our students, and then it's possible to kind of quote from the reader, similar to the previous speaker. You can then say, you answered you gave the wrong answer, and this is the part of the reader that you kind of need to reassess and need to take in more. We're already working on that. Another one would be to get rid of the multiple choice questions, because I think especially in the AI world, it's very important to have this ready knowledge. And I think multiple choice questions aren't testing that as well as open questions would be. So as long as we are able to reduce the workload, right, for the people grading it, it would be very interesting to get rid of those types of questions. I also think it's interesting for scientific surveys, especially in the humanities, where qualitative research happens a lot with people answering questions. You can use a system or the software that I've already been building. You can use that software to make the answers suitable for SPSS, for instance, like some kind of statistic program that can't really use the exact text, but it can work with the different enums and can do analysis on those. So I think that is interesting. And then the final one is a more commercial. You have these questions that are, would you recommend product Y to your friends and family? Yeah, that's something that became very popular in the 2000s. And I think that this is a time and age where we can actually have a bit more of a deeper conversation almost with customers of products in order to really make an improvement. So I think that's also where this question answering and evaluating those questions and software that does that can be a very interesting approach. That's me. You can maybe make a screenshot of the QR code to get into contact, and thank you very much.